So in this video, we have a velocity time graph for a particle, and what we need to do is to estimate the total displacement of the particle across the 50 seconds. And I'm going to use the trapezium rule in order to do that. Now, you could, of course, if this was on graph paper, you could count the squares, but it might be quite laborious to do that. So the trapezium rule will probably be a good way of estimating this. The first thing we need to do is to decide on the width of each of your trapeziums, the strip length, okay? Which, we could, for variety, because we used 10 in the previous video, let's go with 5, okay? So we're going to use strips of length 5 for this. Now, all of my distances, or my lengths rather, on the graph are in centimetres. So this is actually 50 centimetres, this is actually up to 35 centimetres, okay? So that makes it easy for me to measure each of the heights. Okay, so what I need to do is I need to draw a vertical line for each of my points to the top of the graph. Okay, almost there. Last one. There we go. Okay. And then I need to measure each of these lengths. Okay, so first of all, it starts at the origin. It starts at 0. Okay. Then I've got this length here, which is bang on 5. So that's 5. Okay, next one is 15.5. So 15.5 for that one. Then we've got, that's 23. Then we've got, that's 27.5. Then it's about 29.5. Okay, then we've got 25 for that one. Okay. All right, then we've got 22. I'm raising some of my numbers. Then we've got 22 again. Then we have, what's that, 17? And then we're back to 0. Okay? So, the area is equal to 1/2 times h, which is 5 in this case, times by the first, which is 0, plus the last, which is 0, plus 2 lots of the rest. So that's 5 plus 15.5 plus 23 plus 27.5 plus 29.5 plus 25 plus 22 plus 22 plus 17. Okay, so first of all, I'm going to work out what's inside this interior bracket. So 5 plus 15.5 plus 23 plus 27.5 plus 29.5 plus 25 plus 22 plus 22 plus 17. So that's 373 over 2. Then I'm going to multiply that by 2. So now we're at 373. Adding on 2 zeros, that isn't going to change anything. Times by 5, divide by 2, and we should get 1865 over 2, which is 932.5, and this would be in meters. And so that would be an estimate for the total displacement of the particle in those 50 seconds.